convenience we used to randomly collect the data, take the average and take it as a reference point for the rest of the regions. So is it a correct way to do it? Or?
It is, yeah, because you're looking at change. You are assessing change rather than an absolute value. Now it's different if you are to do that to assess the strain, absolute strain or stress in a rebar or metal surface. Then you need an absolute value. If you are in the long term, you're only looking for change. For change, a ratio is sufficient. And you can decide whether that ratio is positive or negative for you. If it's in the resistance, this is good and this is bad. It may not be the same for strain. But if you want an absolute value for strain to calibrate your model, then you need to find a method of getting an absolute value of strain, whereby you need to run trial tests to rule out all the possibilities of either the glue or the fixing method influencing your values. Best to work with one of the knowledge providers, universities where they have the capability. You can give them the assembly and then tell them to figure out what the actual strain is and what the strain your sensors are giving. And you can try different assembly methods. Any other questions? Questions? 1 second at the back. Yeah. Okay. Good question. Why do you think they're there? Yeah. So the resistance is low here, parallel to the temperature being high. Then the temperature drops, okay, and the resistance naturally increase. This gap is between day and night. So it's a diurnal variation that you're seeing. Not technically. This is a couple of cold days. Okay. So let me see if there's a zoomed in information somewhere. So this is a bit more zoomed in. So that's January to February, and then there's a gap, and then up to May or June. So this tiny variations in resistance is due to day and night variation. Okay. So, and it won't be a perfect smoothened line. It should be, because it's a resistance. You should get it smoothened, but none of the compensation techniques available will give you a perfect line. So the diurnal variations will play a part. Assuming nighttime temperatures are low, that'll play a part. What I don't know is what's the effect of sunlight radiation onto that. Sunlight is quite far away, so compared to the layers that you go into the structure. So I'm not sure if that's an influencing factor. Whatever that is, I'm aware that there is the day and night variation. Okay. Which I was expecting I'm going to get a smoothened line when I do the temperature compensation, but you're not going to get. Highly likely, you know, the activation energy that I got here, highly likely that's different when you have in different temperature. So even you might have a micro change due to temperature. This is a temperature compensation, but it might be that it have a nighttime value and a daytime value, and this is an average. Because I'm getting this from the average. Okay. So yeah, but that's data for you. The question is whether you can take the right decisions using the data. The data will tell you something and you need to take the decision. Okay. Any more questions? Don't know. It's commercial, so they have to tell us. But all we know it has latex in it. Latex in it. Rubber. So it's latex coating essentially. But I think the technology might work that it's in plates, so that the plates can lift to breathe the vapor moisture in. It's almost like you're packing the leaves in a certain way. The actual water can't go through it, only the vapor moisture can go between them. Okay? So that might be the way they're breathing out. These are quite often, a lot of these are based on nanotechnology, so we don't know what other techniques that they have built in. Okay? But it's not a new material. I mean, latex-based material has been around for a while. Not sure, but would you have used breathable, like latex-based waterproofing? Okay. So they have the figure, they have the cost. Is it to stop from?
Sometimes they need absorbing the heat, whereas the moisture inside to keep them cool inside. Nowadays, the ladies also for the driving the scooter, they use the technology is there.
So it will become cheaper as more people use it, and then we'll be able to apply on the structure. I take a view that every structure is a living being, and it behaves like that. This is a structure where I'm trying to do a bit of CPR to keep them alive a bit longer, and I know, and the client knows that I'm buying 10 years, 15 years, and the client is very well aware of it. It's a bit of politically sensitive bridge, so we couldn't really take it down. We can't take it down. And also, this happened to be now one of the oldest bridges in Ireland. Not the oldest bridge, one of the oldest bridges in Ireland. Ugly, however that is, but it is what it is. They then classify that under a listed classification. So this is a listed bridge. So we're not in the luxury of taking it down anymore. Okay. I have one more case study, but I don't think we have the time for it. It was a bridge which it's a steel bridge with a concrete top, concrete deck, and it had low cover, but it was near a bus and a train line, bus stop and a train stop. So basically there was spalling happening on the structure, and the steel columns were getting corroded because there were a box section and the water was coming in. It was again to do with drainage. Drainage seems to be the biggest challenge for us with salt water. There was some carbonation in the structure because you should presume there's a lot of buses and trains there, diesel trains. We installed anodes in that case as well. But the concrete also had calcium chloride salt. So as an accelerator, it used to be a thing in the past. So we had to then take it down step by step. The slab didn't need a reinforcement, same principle as here, compressive membrane action. There's a standard that you can download called Highways Agency compressive membrane action or arching action capacity check. Highways Agency documents standards you can download, I think. But that allows you to check whether slab needs reinforcement or not, and you'll figure out probably if it's restrained, it doesn't need it, as long as it has thickness. Same in the other bridge. And then we suggested to do the waterproofing coating on the top, let the concrete breathe out, and put waterproofing topping at the bottom. So construction sequence was staggered over 2 years. And anodes were installed, and then after 2 years, waterproofing was applied to the bottom. Because carbonation was an issue, cover was again non-existent at times. The same repair method, but you always have to remember, if you have something in the structure, how do I get it out? And then seal it. If you seal it in, make sure it's not liquid water because you're in for a treat then. Often what we do is wherever we see an expansion joint or a construction joint, we'll find a way of getting the water out of there. Okay, so in this case as well, we did exactly the same. We tanked it, called waterproofing tanks, just like a water tank, in the hope that that waterproofing will remain in place for another 5-10 years. Waterproofing has a definite life, so don't rely on it forever. Unless if it's been exposed to UV, the damage will be faster. If it's protected from UV, you might get lucky to get 15, 20 years. Okay. So yeah, that's how decisions can be made. You know the answer to a lot of questions that you're already looking at, but the best thing to do is to put a sequence of events, put a timeline, and then say, I'm going to do this for this reason. And try to educate the contractors involved, because they have to play the part in delivering your vision. So make it visible for all of them. So that's all I can say about performance-based specification and testing. There's an area that I did not cover, which is performance-based specification. Performance-based specification. It's simple as that. You know the way you did the carbonation modeling and you were asked to do the chloride modeling? The way it works is you take the most critical parameter of that, which is diffusion or binding, most likely diffusion, and you specify that value rather than saying what mix design to use. So you absolve yourself from specifying the mix design, but you just say, provide me a concrete with a certain diffusivity or below. However they can achieve it is theirs. There is a give on it, in the sense that the supplier then can go and find materials suitable for them and their environment, rather than having to comply with your perfect silica fume or PFA or GGBS standards. Okay, so if they find they can tap into a PFA plant, they can then provide you that cheaper and better, because that's what they do all the time, and they know the mix design quite well. So you give them a bit more flexibility. In return, you get a concrete of known performance. So that's performance specification for concrete. There's a RILEM standard, RILEM proceedings on it. So there are a few test methods being put forward. European standards will now start to change in accordance with that. Inspired from it, not necessarily agreeing to it. So if you're in the business where durability is a concern, find out what concerns you the most. Put a performance specification for that concern. So if you're testing out a structure that has moisture issue, then moisture related performance test should be in the spec. Try not to be very restrictive by saying this is the mix design you should use and this is the performance you should achieve. That is not really productive for the supplier, because you're basically tying everything and they have no flexibility to move. And try not to bring the supplier to new concretes all the time, because they're so used to supplying something that they do all the time, and ask them to make that better rather than giving a complete new spec. That's a sense of performance spec. Okay. So I'm going to stop there. You can ask any other questions you have with me. A bit later on in the year, we will start to release some of the information through either a new website or through publications. So keep an eye out on the Queen's publication page, or if you're in ResearchGate or any of those networks, then you'll be able to get all the publications coming up. Feel free to add me in LinkedIn. If you have my email address, you should be able to add me in LinkedIn. And anything new, any jobs, any other work that we do, we put out in LinkedIn. We have to be seen very public these days. So I'm an ambassador for the university. So everything that we do, including this, is in LinkedIn saying I'm doing this. So okay. So any questions, ask me. I'm going to be here. So are we wrapping up? Yeah. Okay. No questions? Did you enjoy it? Was it life cycle management of if you look for whole life management, there are some books available, but most of it is, rather than books, it's the reports from technical or professional bodies, because they're the ones who go first and then the books will arrive later. So there are technical reports available on whole life cycle or life cycle management. Quite often there are research projects and they have the output published, and you can download the output for free. Any European funded research project, the output will be free. You should be able to download it from the web, okay, which you should, because it's free. The intended purpose of European Union was that if we're as taxpayers funded, the output should be available to taxpayers and growing nations. That's their view. If the research is not useful, then it shouldn't be published. It shouldn't be funded. Okay. It's quite a strong view, but it's good. Yeah. Yes, always, always. You should only use things that you are confident that you get the results the way you want it. It's not given, always. So, if you have not used a particular sensor before, my suggestion will be to use it in a weaker environment. Create a weaker environment, use it, get the data, have a feel of how the data comes to you, and see what interpretation you can make. You should be able to do that challenge using a bucket and sand mixed with bentonite clay. That's your concrete. So take bentonite clay, which is absolute permeability of close enough to 0, and then you mix it with sand so you can increase the permeability of it, the water filtration. That means you can take it apart, you can put your sensor, you can put the bentonite clay back with the sand, and you put water on the top of it, or you change the temperature, or you do any environment that you want to, and see what values you get out of it. This is for durability. So stress and strain, work with one of those people that have the capability to apply the stress or strain, get the values out of it to see